Hi students, in this video I'll be going through the 2022 A Math Paper 1 question 6. Alright, so this is a question regarding integration, right? Okay, so let's read the question. So a curve is such that d2y dx squared is equals to 2 times e to the power of negative x plus 6 times e to the power of 2x. Alright, the curve intersects the y-axis at t 0, 5 and has a gradient of 3 at t. Okay, find the equation of the curve. Alright, so you see that this question over here is a 7-mark question. Okay, but when you see a question like this, it doesn't mean that it's going to be very difficult. Okay, so let's analyze the question in a calm manner. Okay, so over here you see they give you a d2y dx square, right? Okay, so this is the second derivative. Okay, okay, so d2y dx squared is 2 times e to the power of negative x plus 6 times e to the power of 2x. So this is the second derivative, right? Okay, so if we were to integrate the second derivative, then we will get the first derivative dy dx, which is actually the gradient function. Okay, then you go back to the question and ask yourself, did they give you any information regarding the gradient? Okay, so over here we can see clearly that they told you that the gradient, okay, at p is 3, right? Okay, that means they are saying that remember gradient is the dy dx, the gradient function. So that means they are saying that dy dx is equals to 3 at point p. Okay, and did they give you the coordinates or any information about p? Okay, yes, indeed they give you. Right? In fact, we know that the x coordinate at p is 0 and the y coordinate is 5. Okay, this means that we should be able to formulate an equation using this information, and that will allow us to find the dy dx function. Okay, because remember when we integrate d2y dx squared, okay, this is an indefinite integral. We are going to get a constant behind, and this information will allow us to formulate equation to find out constant c. Right, so let's try out. Okay, so we're going to find the gradient function, so dy dx. Okay, so dy dx will be 2 times e to the power of negative x plus 6 times e to the power of 2x. Okay, so we're going to integrate. Alright, so when we integrate 2 times e to the power of negative x, okay, remember exponential function is very easy to differentiate or integrate. Okay, so when you integrate, everything remains the same. Okay, but what you want to do is you want to differentiate this power here. So this power is negative x. When you differentiate, you will get negative 1, right? And then since we are integrating, we will divide by negative 1. Okay, then the same thing for the second exponential function here. Okay, remains the same. Okay, then you differentiate the 2x on top, you'll get a 2, and you divide by 2 here, and then you get your plus c. Okay, so in other words, dy dx will be equals to negative 2e minus x plus 3e to the power of 2x plus c. Okay, and you can see that over here there's this constant value, right? And an unknown. Okay, so that is where this information will come in and help us. Okay, so at the point P, which is 0, 5, dy dx equals to 3. Okay, so at P, okay, which is 0, 5, okay, dy dx equals to 3. Okay, so at point P, x is 0. Okay, in other words, they are saying that when x is 0, dy dx is equals to 3. So now we are going to sub 0 inside here, and then equate this whole thing to 3. All right, so minus 2e minus 0 plus 3e 2 times 0 plus c equals to 3. Okay, so you will get minus 2 here plus 3 plus c equals to 3. So c will be equals to 2. Right? Okay, so now that we have found c, we know the full expression for dy dx already. Okay, so dy over dx is equals to negative 2e minus x plus 3e 2x plus 2, right? Okay, but remember this is not the end of the equation. They want us to find the equation of the curve, That means they want us to find y equals to something something, okay? Find the equation of the curve, which means that we will now need to integrate one more time. Okay, so to get y, we will integrate dy dx. So y will be, we're going to integrate this whole thing. Okay, with respect to x. Okay, so same thing, we integrate, you get this. Okay, differentiate the power, you get -1 and divide below. Okay, so this one will be the same thing. Differentiate the power 2x, you get a 2 divide below. And we integrate 2, you just get 2x. Okay, then there will be another constant. Okay, this time we're going to call it C1. Right, so now that we know y already, yeah. Okay, so now that we know the expression, okay, so now we need to find C1. Right, and do we have enough information to find C1? Yes, indeed we have. Okay, in fact it's given at the start of this question. Okay, the point P, the curve intersects the y-axis at P05. That means the curve passes through P05. That means for this particular curve, when x is 0, y is equals to 5. And this information will allow us to find the C1. Okay. Okay, so we'll write over here. Okay, since the curve passes through P05, y equals to 5 when x equals to 0. Okay, so y equals to 5 when x equals to 0. So we'll sub x to be 0 over here, here, and here, and then equate it to 5. Alright, so 2e minus 0 plus 3 over 2e to the power of 2 times 0 plus 2 times 0 plus c1 will be equals to 5. Okay, over here you get 2, over here you get 3 over 2, over here is 0, so plus c1 equals to 5. Okay, so here will be 4.5, so 3.5, sorry, bring over you'll get 1.5, so c1 will be 3 over 2. Right? Okay, so since we have found C1, then we have successfully solved the question. Okay, because now we know fully the equation for the curve. Okay, so y will be 2 to the power 2 times e to the power negative x plus 3 over 2 e to the power 2x plus 2x plus 3 over 2. Okay, so this will be the solution to the question. Okay, so it's a 7-mark question and there's no guiding step. Okay, but it doesn't mean that the question is going to be very difficult. Okay, in fact, exponential function very easy to differentiate, also very easy to integrate. Okay, and just scan the question and write down the information that you have and think about how you can use it to solve the question.